Hi everyone, we're here to discuss chapter 10-3 in your algebra text. We are going to be working on operations with radical expressions. Radical expressions. Remember what radical means? Totally gnarly, right? Radical, dude. Okay, so enough with the fake surfer thing, which I can't do anyway. Radical means anything with a square root. That is our radical sign. So you already know some of the tricks that we can use with radical expressions. For example, you know if we have a square root of 6 times the square root of 6, that's the same thing as the square root of 36 because you can multiply the things underneath the radical together to get another number. And you know that the square root of 36 is just 6, right? You also know that if you take a square root times itself, the answer is just going to be what's in the inside anyway. So we could have used that to just shortcut our square root. So we're going to learn a few more tricks today, not very many. The first thing is when we're adding things such as 5 times the square root of 2 plus 7 times the square root of 2, and then maybe we've got a minus 6 times the square root of 2. When we have the square root of 2 and the square root of 2 and the square root of 2, we can just add the coefficients. It's just as if that square root of 2 is a variable. You can treat it pretty much the same way as if it was an x. So we have 5 root 2 plus 7 root 2 minus 6 root 2. Well, 5 plus 7 is 12. 12 minus 6 is just 6. So that answer will be 6 root 2. That's not so hard, is it? I want you in your book on page 619 to look at letter 1A and 1B and see if you can get those answers on your own. Pause the video, work on your own, and come back and we'll see if we can get it right. So 1A turns out to be 3 root 2 minus 5 root 2 plus 4 root 2. Again, we've got that same square root here, here, and here. So 3 minus 5 is negative 2 plus 4 is a positive 2. So the answer will be 2 root 2. 1b is very much the same. It's 6 root 11 plus 2 root 11 minus 9 root 11. Okay? Pause it. Make sure you try this on your own before you watch my answer. 6 plus 2 is 8. 8 minus 9 is a negative 1. So my answer is a negative 11, negative root 11. Now, if you are still writing a negative 1 root 11, it isn't wrong, but I really want you to stop doing that. You don't have to have that 1 there to know that it's a 1. You're wasting your pencil lead. Save it for something more important, like that negative sign. Alrighty? Okay, one more example. I want you to pause the video again and try 1D on page 619, 1D. Pause the video. Here we go again. 4 root 3 plus 3 root 7 minus 6 root 3 plus 3 root 7. Now I can add this 4 root 3 minus this 6 root 3, and that's a negative 2 root 3, right? But I can't add them to these 7s because it's a different number underneath the radical sign. So here we have a 3 root 7 and a 3 root 7, so that's going to be a 6 root 7. If I were multiplying, I could multiply those numbers underneath the radical, but I'm not multiplying, I'm adding. So this is as simple as it gets. Alrighty? Okay, so I hope that makes a lot of good sense to you. We are going to turn the page and keep moving on page 620. We have more examples where the radicals are, or radicands, the number underneath the radical, is not the same. So I apologize for the extra sound effects in my house today. We have 2 root 18 plus 2 root 32 plus root 72. Now it doesn't look like any of those are the same, but we should try to reduce these or simplify these radicals in order to see if we can add anything together. So square root of 18. What is the square root of 18? That is going to be 9 times 2. I know the square root of 9, so I'm going to circle just that. And I know the square root of 9 is 2. So this becomes 3. 3 times 2 is 6. So 6 root 2. That 2 just stays right there because I can't find a square root of that. 32. Let's see. 32. You might say it is 8 times 4.
She laid something on the floor.
I'll talk to you later, Frank. Bye. Sorry about that. And you know that 8 is 2 times 4. I've got 2 4s here, so I'm going to split both of those. So I'm going to take one of those out, and I'll have 4 times 2 is 8, and I have a square root 2 left. So here's a 2 and a 2, right? I can add those together. That's good. Now the square root of 72. Let's see. That I know is 9 times 8, and 8 is 4 times 2. So I can take that 9 out, and it will become a 3. I can take that 4 out. It will become a 2. So I will end up having 6 square root 2. So now I have 6 plus 8 is 14 plus 6 is 20 square root of 2. So now you can kind of get an idea of why it's so important to reduce these radicands so that you can see when they're the same. We just couldn't tell that they were the same before, could we? Okay, so again, I want you to pause the video and do letter 2A. 2A on page 620. 4 times the square root of 54 plus 2 square root of 24. You already have your answer because you paused the video. Okay, 54 is 9 times 6. I know the square root of 9. I know 6 is going to be 2 times 3, so I can't reduce that anymore. 3, because the square root of 9 is 3. 3 times 4 is 12 times the square root of 6. Here I have a 24, which is going to be 4 times 6. Oh, I see that 6 again. I've already got that 6. So the square root of 4 is 2. 2 times 2 is 4 root 6. 12 plus 4 is 16. I still have that root 6, which doesn't change. And the answer is 16 root 6. If you want to check your work and continue to practice these, the answer for 2B is going to be negative 16 root 3. 2C will be 4 root 5. And 2D is 3 root 6. So go ahead, pause the video, and see if you get these answers. If you don't, bring them to class, and we will answer them. We will get the right answer and figure out where our mistakes are, because that's the big battle. Last example that we are going to do right now is when we're multiplying. This shouldn't be too hard. So if we have an example like 3 times the square root of 2 times 2 times the square root of 6, you can right away multiply the numbers that are on the outside. So 3 times 2 is 6. And you can multiply the numbers that are on the inside. 2 times 6 is 12. And you've got to keep that answer inside. Now let's see if we can simplify this 12, because the square root of 12. Let's see, that's 4 times 3. I know I can't reduce 3, but I know the square root of 4 is 2. 2 times 6 is 12, and I still have a square root of 3 left. You try to do letter 3C on the bottom of page 620. Just use the same rules you've already know. Pause the video to do 3C. 3C is 3 times the square root of 2 times 4 root 3 plus 6 root 2. That will be 12 square root of 6. Remember, it's just the distributive property. I'm going to multiply this times the first thing, and that again times the second thing. 3 times 6 is 18. Square root of 2 times square root of 2 is square root of 4. So 6 we can't do anything with. That's as good as that one gets. That's simple, right? Because that's 2 times 3. We can't do any square roots there. And the square root of 4 is 2. So it's going to end up being 12 square root 6 plus 18 times 2, which is 36. Final answer. Now that we've done 3C, let's try that again with 3D. Be sure to pause that video. Pause the video and do 3D. 5 root 3 times 3 root 2 minus root 3. This is 15. Remember to multiply the things that are under the square root sign. Radical 3 times radical 2 is radical 6. Minus 5 is the only thing outside, so it's 5. And root 3 times root 3 is root 9. So 15 root 6 minus 5 times the square root of 9, which is 3. So 5 times 3 is 15, and that's our final answer. Okay. Go ahead and try your homework. We will answer questions in class. See you tomorrow.